So this is going to be the video for section 3.1, which is the introduction to the derivative of a function. And if you look, I'm on page 99 of your book. This right here in tan is the definition of a derivative, f prime of x. This is the difference quotient from chapter 2. See, this thing's undefined, this fraction, when x equals 0. You can't have 0 in the denominator. So that's the whole point. You have to put the limit as x goes to 0 in front of this, so this gives you the derivative. Now, in the textbook, there's two examples. Example 1, they show this derivation. They're doing this the long way. You're not going to have to do this once we get through next week. But this is just the difference quotient. It's y, the difference of the y's, you have the difference of the x's algebraically, and it gives them the derivative of that function. Then they get to a different function, and they use what's called the alternate definition. Okay? Actually, College Board sometimes will bring up this definition in a multiple choice question that you'll see in May. But I'm just going to focus on the actual, we're going to do this, show you this function with the alternate definition and the traditional definition, and that's what's on here on the PDF. So here's example 2. The definitions to the left, the alternates to the right. This is what's in your book. This is what's not in your book, because they did this for example 1 only. But this is more, I don't know, I just think this makes more sense. So, ready? Yeah. We have this t-chart. The function is root x. So your input's x, and your output's root x. So what are you doing? You're moving h units to the right. And when you move h units to the right, it becomes our input. And for the derivative, we want the change. We want the slope. We're going to subtract up. This, take away this, over that, take away that, and that's this line right here. And what you're trying to do is you're trying to connect the difference quotient with the t-chart. So we did it for you right here. If you see a difference quotient, you got to be able to work backwards and build a t-chart. So I go from here to here. What happened? The x is added to 0. Now what? Well, they multiply by the conjugate of the numerator. You've never seen that before. You've multiplied by the conjugate of the denominator when you were trying to get root signs out of the denominator. You might have multiplied by the conjugate. But it's in the form of, ready? A take away b times a plus b would give you the difference of squares. And the difference of squares would get rid of all these root signs. So you would just get the first term, x plus h, root x plus h squared, which gives you x plus h, subtract root x squared, which gives you x. You don't have to understand why they did this, just to follow it. So now we have h, this denominator, distributed over this denominator. Over there. In the top, these x's would add to 0. This h in the denominator would reduce with that h and leave you with a 1 up there. Now what? Now nothing. Like you have to say the limit of this is h goes to 0. That's why you did chapter 2. So if you do that, your denominator would be root x plus root x. Now this is not two fractions. This is all in the one denominator. So you would get 1 over 2 root x. That's the slope of that function. What does that mean? You just watch this. You don't have to do this. I'm going to go to the calculator. I'm going to type in y equals root x. Okay? And we said the derivative was 1 divided by 2 root x. So let's see if we can make sense of this. The parent graph is going to be blue and the derivative is going to be red. Well, it kind of makes sense, I hope, because what are you looking at? The blue graph is going up in quadrant 1 the entire time. The red graph is in quadrant 1. The red graph's a derivative. It's positive. That's telling you the parent graph is increasing. Now what? Well, I just did this in y equals. I did this the long way. Did the algebra. We have the difference quotient already in here. It's the same thing. You have to make this connection. It's in y5. So if I turn on y5 and I go to the table, second graph, I want to see if these values match up. And they do. The values are the same, which is telling you what? That you calculated the derivative correctly. Y5 is verifying that numerically for you. And we have an error at 0 because our derivative can't take on 0 because we have root x in the denominator. Y5 can because we define that with h going to 0 or h going to having a value of 1,000 going to 0. But you can do this for all of the rest of the book. If you're asked to differentiate something, you put the derivative in one of the lines, you put the parent graph in y1, you turn on y5 and see if those t-charts match up. Okay? So you're going to do this algebra here for problem number 5. Now, if you look at 5, it says use the alternate definition. I did not use the alternate definition in the solution. I did it this way, okay? So it's better for you to make this your model as you do the algebra. You don't have root signs. You're not going to have to multiply by the conjugate. You're just trying to do this. You're picking up here. Subtract up. Build a t-chart. Subtract up for 5 so that you can identify the function that is the derivative of the parent graph. Okay? All right. Now I see a lot of people, their head down, they're still working. We're just going to go over this, see how far you got. All right? Here's the key. Ready? Here's the t-chart. X and Y. What do I have? I replace x with x plus h, so I replace the function with that. And here's my difference quotient. I'm subtracting up. This, take away this over that, take away that, and these x's would add to 0. So now what? In order to do this numerator, I'm subtracting fractions, so I bow-tied it. I multiplied across the denominators, and I got this denominator. Then I multiplied by diagonally, and I subtracted. So I took this 1 over h, which I took this h in the denominator and wrote it as 1 over h in front of this whole thing. There's a negative sign in front of the parentheses, so I distributed a negative 1 over what's inside there. The x's would add to 0, the h would be negative. This h would reduce with that h. You're taking a limit as h goes to 0. You'd have negative 1 over x squared. That would be the derivative of the function of the parent graph. And at input of 2, you would get a negative 1/4. So I go to the calculator and I type this. Ready? Negative 1 over x squared into y2. Now, first, you're just going to look at this. Does this make sense? The blue graph is falling on the entire domain from left to right, and the red graph is below the x-axis. So that's telling you the red graph is negative. Now what? The red graph is telling you it's negative, which means the parent graph is falling. Go back here, and I quantify it. So I'm going to turn Y1 off. I'm going to turn Y5 on. It's the same T-chart, which is confirming you correctly identified the derivative. And what are we getting? Negative 0.25. That's the slope. So that means the tangent would have a slope of negative 0.25. If I go back here, I could draw the tangent line. It has a slope of negative 0.25. What are we doing with x? X subtract the input, 2, we're sliding it 2 to the right, plus the height, which we said was 0.5. You put 2 in the function. If I put 2 in y1, I get 1/2. Here comes the tangent line, the black tangent line. So you got a lot going on in this screen. The blue graph is the parent graph. The black point, the black box was given to you. They said an input of 2 on the parent graph. The issue is this blue graph has a different slope depending on what point you pick. If you pick 2 to the right, the slope of the blue graph, the instantaneous change is negative 1/4. So that tangent has to have that slope. Okay, now this is going to be up there. I mean, you can go back and watch this again because this is a big deal, being able to follow this, and this will help you reinforce for you what's on the quiz tomorrow. Now, for example number 3, I'm just going to go with the textbook. Well, before we get to that, notation is important. These are all ways to write the derivative. Y prime dy dx means the derivative of y with respect to x. This is just a different letter, F instead of y. This, what'd you do? You took this y and wrote it out front. The derivative with respect to x of f of x. They all mean the same thing. So, and again, the picture is important. The picture's important, okay? And this might seem, oh, good, I get to deal with pictures. This is challenging. You need to get on board with this example 3. So the blue graph is the parent graph. I'm sure they're both blue. The one to the left is the parent graph. What they want you to do is draw the graph of the derivative. So look how they did this. They have this point A. And where is A? 0, right or left, up 1. That's where A is. So they want to find the slope of the parent graph at A. So they made H1. So they went out here and built this triangle, which has a base of 1. And here comes the tangent from A. And where's this triangle meet the tangent line? At 1, 5. For finding the slope, which is the difference of the y's. 5 take away 1 over the difference of the x, take away 0. So that's a slope of 4. So they went over here and put a, ready? When the input is 0, the slope is 4. Now what? We're not going to do every point. Go to C. See what's happening? C is 2 to the right, looks like up almost 5. We can tell this is where the graph is peaking. So the tangent would be horizontal, would have a slope of 0. So here they went to C. When they identified the slope, they put a 0. You go to E. They're telling you the slope for E is -1. Slope for F, another horizontal tangent. And they connected these points. This is the derivative of that. Now that seems kind of confusing, and it is. So instead we have this, well, in addition, we have this for you to do. Ready? You're not going to do this, you're just going to look up here. In Canvas, you have a link in the Chapter 3 folder to the big derivative puzzle. This is the big derivative puzzle. It's like what you just did in the book, except it's a little more user-friendly. So now what? They want you to match these derivatives to those parent graphs. Now, the only thing about the big derivative puzzle is this. We have had issues in the past with people using their Chromebook to do this. So I would strongly suggest, if you're having an issue, go to your parent's desktop, because this is really helpful. So let's try one, see if this works. I think this maps onto that. So I drag it up, true. That was just a good guess. I go here, false. It didn't work. So let's give some thought to this, okay? This graph here is doing what? It's a parent graph. It's falling to get to -1, and then it's rising. So its parent graph, the derivative, would have to be negative before you got to -1 and positive after that, which is this graph. True, okay? And nobody's keeping score here. You can do this and refresh this page as often as you want. But the link for the big derivative puzzle is in the Chapter 3 folder on Canvas. Okay, which is more helpful than this, okay? So we're going to go on to the next thing, which is a little more user-friendly than, well, not the technology. Here's example 4. Now, example 4 is over here. Do you see how these two graphs match up? They're giving you the derivative. Ready? The derivative changes when x is 1. When you're to the right of that, the slope's 2. When you're to the left of it, slope's -1. They tell you that 0, 0 is on the parent graph. So here's 0, 0. Now here's what's tricky about this and the problem you're going to turn in. The given point doesn't match up to the vertex of the graph. That's what makes it a little challenging. So just go up here, ready? He told me 0, 0. I look up here. When x is 0, the slope is -1. So I go 1 to the right, down 1. If I'm going right to left, I go 1 to the left, up 1. Then once I get to 1, the slope changes to 2. So from here I go 1 to the right, up 2, and then this is the parent graph, and that's the derivative. So you basically went opposite of what we've been doing by graphing the parent graph in y1. Now we're building the parent graph based on the derivative and enough given information, an initial point. Okay? So we're gonna pause the video and you're gonna go here. You're gonna go to problem 27. You're gonna try and reproduce this freehand. And that's what you're gonna send in. Okay? So for 27, okay, I've got this picture right here. I use the graph link. I don't want you to use a graph link. Don't worry about what's in y equals like this. Just build it by hand. So what's given? what's given is the initial point, 0 right or left, down 1, right here. And they're telling you that the slope changes when the input's -1. So this vertex does not match up to that given point. So when I'm to the right of -1, they tell me the slope's -2. So I'm going from right to left. So I would go 1 to the left, up 2. So therefore the slope would be negative as you're going from left to right. And from there, the slope becomes -1. So I would go 1 to the left, down 1. I'm sorry, then it's positive. I'm sorry. 1 to the left, down 1. Then the slope is +1, -2. So the actual vertex is at 1 to the left, up 1. At every point, ready? The slope changes when the input's -1. What they don't tell you is the vertex, which is 1 to the left, up 1. You had to count this units when you drew this freehand. Okay? Now, that is not on the assessment. What's on the assessment, which will help you reinforce this, is the difference quotient. Okay? What's going to happen is tomorrow we're going to move forward and do 3-2. You take your assessment on Thursday, and then after that, these lessons will be multiple day lessons. So chapter 1, chapter 2, and the first 2 sections of chapter 3, we went pretty fast here. All right, so that's it for the recording.